In this demo, we're going to perform a SQL injection attack using sqlmap. First, we're going to install sqlmap. Then we're going to execute sqlmap through burp proxy. And then we're going to review the results. There are some prerequisites to this demo though. I do assume that JuShop is up and running and listening on port 3000. This is one of the steps that we did in a previous module, the one about attacking web servers. Then you also need to have Python 3 installed, because that's what sqlmap is, a Python package. And you need to have Burp Suite installed. We're going to use Burp Suite as an intercepting proxy server, so we can actually see what sqlmap does. Let's go to our console. Let's check whether I have pip installed. Pip is a tool which makes it easier to install packages using Python. I'm going to execute the command pip -- version, which should show me which version of pip is installed. Great, it's installed. Now I'm going to install sqlmap, and I'm going to do that using the command pip install and then the name of the package, which is called sqlmap. Great, sqlmap is installed. Let's clear the screen. sqlmap -- help gives you all kinds of information on how you can use sqlmap. What we are trying to do is run sqlmap through a proxy server, Burp Suite, and then try to attack a specific URL. And that URL, we think it hides some kind of SQL injection vulnerability. Let's clear the screen and execute sqlmap. And we're going to use the parameter proxy to specify the address on which our Burp Suite intercepting proxy is listening. And I know for my local instance, this will be 172.30.160.1 port 8080. And then I'm going to pass it the URL on which I think there will be a SQL injection vulnerability. And I found this URL just by trial and error. This is not part of the demo, this is just showing how sqlmap works. Then I'm going to pass in two other parameters. First -- level, which means how hard sqlmap is going to try to find a SQL injection vulnerability. And then -- tables. With -- tables, I instruct sqlmap to dump the name of the tables in the database if it finds a SQL injection vulnerability and if it can exploit that vulnerability. As you can see in the background, sqlmap detected a SQL injection vulnerability. It also properly fingerprinted the underlying database engine, which is SQLite in our instance. I'm going to let sqlmap run in the background with all the defaults that it suggests. And as you can see, it found a blind SQL injection vulnerability or an inferential SQL injection vulnerability. This means that it only can use the data channel for 1 bit of output. But, as you can see on the screen, that single bit of output still is enough to exfiltrate the name of all the tables in the database. That is pretty impressive, right? That even with inferential SQL injection, where you only have 1 bit of output, that still sqlmap is possible to exfiltrate all that information. Now let's switch to Burp to see what it is doing in the background. And here you can see the thousands of queries that sqlmap is running against our target in order to try to find all that information, in order to exfiltrate all that information. And if we scroll through all the different requests of sqlmap, you can see how those requests are built up. That is the beauty of using a tool which can perform that SQL injection attack automatically, that even if you have only an inferential or blind SQL injection vulnerability, that you're still able to exfiltrate so much information. In the next clip, let's take a look at some evasion techniques that you can use.